Good morning, students. So today's class we are going to study about the design of Butterworth filter using impulse invariant method. So the given problem is we have 0.707 less than or equal to modulus of h of e power j omega less than or equal to 1, where the angular frequency omega varies between 0 to 0.25 and the modulus of h of e power j omega less than or equal to zero point 0.1, where omega varies between 0.55 to 5. So in this, the given data is A1, A2, the pass band gain is A1, stop band gain is A2. So A1 is 0.707, A2 is 0.1. And the two frequencies, omega 1 is 0.25 and omega 2 is 0.55. With these four data, we have to design the filter, Butterworth filter using impulse invariant method. The first step is we have to find out omega 2 divided by omega 1. The formula is omega 2 by omega 1 equal to this angular omega 2, that is the digital omega 2 by omega 1. So in this place when you substitute 0.5 pi divided by 0.2 pi, this pi and pi will get cancelled. You will be getting the answer as 2.5. The next step you have to determine the order of the filter. The formula is n equal to 1 by 2 of log of 1 by a2 squared minus 1 divided by 1 by a1 squared minus 1. The whole thing divided by log of omega 2 by omega 1. This omega 2 by omega 1 already we have found out in the previous steps. So in this formula, if we substitute the a1 value, a2 value and omega 2 1 by omega 1 value, we will be getting the n as 2.507. Then we have to rounding off to equivalent integer, so it will be n equal to 3. Now the next step we have to determine the analog cutoff frequency omega c, which is given by the formula omega 1 divided by 1 by a1 squared minus 1 whole power 1 by 2 1. In the place of n, we will be substituting 3 here. So in that case, and omega 1 value as 0.25, a1 as 0.707. So in this, after substituting all these values, we will be getting omega c as 0.628. The next step, we have to determine the analog transfer function h of s. Since n is odd, we will be choosing this formula h of s equal to b naught omega c divided by s plus c naught omega c. The product of k equal to 1 to n minus 1 by 2 of bk omega c square divided by s square plus small bk omega cs plus ck omega c square. So in this place, when you substitute the k value equal to 1 to n minus 1 by 2, so after simplifying, we will be getting k value as 1. So we will be substituting in this formula. So it is b naught omega c already we found at 0.628 divided by s plus c naught into 0.628. In the place of k, when you substitute 1, it is capital B1 0.628 the whole square, the divided by s squared plus small b1 into omega c is 0.628 into s plus c1 into 0.628 the whole square. So the next assumption is for b0 and b1 it is equal to 1 and the c0 and c1 is equal to 1. This is an assumption. For small b1 we have to find out the value using the formula. So the formula is b1 equal to 2 into sine of 2k minus 1 into pi divided by 2n. In the place of n, we will be substituting the 3. So you will be getting the answer as 1. So next h of s equal to, after substituting all these values, you will be having 0.628 divided by s plus 0.628 into 0.394 divided by s square 0.628s plus 0.394. Now in this equation, directly we cannot get the impulse invariant function. So you have to apply the partial fraction. So when you apply the partial fraction, it is a divided by s plus 0.628 plus bs plus c divided by s square plus 0.628s plus 0.394. Next we have to find out the value of a, b and c. So if you solve these particular equations, so first you have to collect the coefficient of s squared. So you will have a plus b equal to 0. Then collect the coefficient of s. You will be getting the second equation as 0.628a plus 0.628b plus c equal to 0. Then the third equation you will be getting it as, when you collect the constants, 0.394a plus 0.628c equal to 0.247. Now, when you solve these three equations, from the equation 1, we will be getting a equal to minus b. Then when you substitute the equation 1 and equation 2, you will be getting the answer c equal to 0. And when you substitute the c equal to 0 in equation 3, you will be getting the B equal to 0 minus 0.626 and A equal to 0.626. So after substituting the A, B and the C value in this equation, we will be getting H of S as 0.626 divided by S plus 0.628 minus 0.626 divided by S square plus 0.628S plus 0.394. Now let us consider this, divide this equation into two parts, first part and second part. So for first part, H of S equal to 0.626 divided by S plus 0.628. So in this, when you apply the impulse invariant method, so it will be 0.626 into e power minus 0.628 t. Then the second part we need to solve it. So in the first part, when you apply the sampling and apply the Z transform, you will be getting the expression as 0.626 divided by 1 minus e power minus 0.628 t Z inverse. Then you take the second part of the equation 0.626 divided by s square plus 0.628s plus 0.394. So in this equation, when you directly apply the Laplace inverse, it is b by s plus a whole square plus b squared equal to e power minus at sin bt. Now we have to bring this equation in this form. To bring this equation in this form, so let us 0.626 divided by s squared plus in the denominator we can write it as 2 into 0.314s. So in the 3.014 is nothing but a. So 3.0 will be adding 0.314 square and subtracting 0.314 square. So in this, when you can write this equation as 0.626 divided by s plus 3 0.314 the whole square plus square root of square will be nothing but just the number itself. So square root that is 0.394 minus 0.314 square the square root of the whole square. So the value is nothing but 0.543 the whole square. So now anyhow we have bring it in the form of b by s plus a whole square plus b square. Now b is 0.543. We need to multiply in the numerator as well as in the denominator. Then when you simplify this, we will be getting 1.15 into 0.543 by s plus 0.314 whole square plus 0.543 whole square. So this we can write it as 1.15 into e power minus 0.314 t sine of 0.543 t. Now in this, if you solve this equation, the sign of 0.540 nt in the Z transform you will be getting like this. So when you solve this, it is 1.15 divided by 1 minus e power minus 0.3414t sine of 0.540 Z inverse. So when you combine the x1 of s and x2 of z, x1 of s is 0.626 divided by 1 minus 0.628 z inverse plus x2 of z is nothing but 1.15 divided by 1 minus e power minus 0.314t sine of 0.540 z inverse. So after substituting the t value as 1 second and simplifying it, we will be getting h of z as 0.626 divided by 1 minus 0.628 z inverse plus 1.15 divided by 1 minus 0.3769 z inverse. This is the answer, you will be getting it.